So this is lesson 83, Algebra 2, product rule with variables and the power rule with variables. And if I remember right, we have already gone over these, so apparently they're going to give us just a little bit more detail here. Alright, so when we have something like x to the third power times x to the fourth power, variables have to be the same, exponents we add, and we're done. That's the product rule. The power rule says that if we have an x cubed and we're going to take that to the fourth power, that's x to the 3 times 4, which is 12. There is no sign between those two. There is a parenthesis that separates them. That means you multiply. There is a sign between these two, and there is no parenthesis, and these are on the same level, so we add them. Notice this level, 3 is lower than the 4. So that's just some clues as far as, okay, when do I multiply? When do I add my exponents? Alright, so that gives us our first example, 83.1. X to the a, y to the 2x, x to the a over 2, y to the 3x over 4. Alright, we can only combine variables that are the same. So we can only combine this with this, and then this with this. And there's no parentheses, so we're going to go ahead and add. X times x is x to the a plus a over 2. Y is going to be the 2x plus 3x over 4. Okay, so we have to add exponents with like bases. So we're going to make this 2a over 2 plus a over 2 common denominators. And this we're going to make for 8x over 4, which is 2x, plus 3x over 4. So we have common denominators. So we have x to the 3a over 2. Add those. Y to the 11x over 4. Okay, and at that point we're done. Alright, let's look at example 83.2 here and see how much different that's going to be. We've got a division here, and we'll get into what we're going to do with that in a minute. So let me pause and write the equation out. Okay, the book does this one different than I do, and I think they do it, to me, it's more difficult. Alright, like we said before, if we have an x squared times an x cubed, what do? We write the variable and we add the exponents. If I had x squared divided by x cubed, I don't add the exponents like I do here in multiplication. In division, I subtract the exponents. Like that. Okay? So that's what we're going to do in this problem that I have written there in white, is we are going to look at each one of the variables and subtract the exponents. So we're going to have x to the a minus 2, and I'm going to put that in parentheses to group it, minus a over 2. And that takes care of that and that. Alright, now let's look at my y's. Y to the a plus 4 minus 2a. Alright, so let's take the parentheses off, and we have a to the a minus 2 minus a over 2, y to the a plus 4 minus 2a. Alright, so we're going to combine like terms. So this one here is kind of messy. So what we're going to have to do here is find common denominators for here and here. So I'm going to write that as 2a over 2 minus a over 2, and then my minus 2. And here I'm going to combine. So let's just go ahead and write that. A minus 2a is negative 1a plus 4. Alright, so let's combine these two. So x to the 2a minus a is 1a over 2 minus 2. And y is going to be negative a plus 4. And that ends up being my answer. So notice what I did here. I took my two terms that I combined, my a and my a minus 2. I can't combine this 2 because there's not an a in there. And I made a common denominator of 2a over 2, which is the same as a, so that I could combine with that, and I got an a over 2, and then the minus 2, it just kind of tagged along. And over here I just took the a minus 2a and got negative 1a, and the plus 4 again tagged along, and I got that for an answer. Alright, let's continue on here with the next example. And the next example we go into power rules. And I had mentioned that if we have x cubed squared, we multiply the exponents. And that's what we're going to do here. X to the a plus 2, the quantity squared means x2. We're going to multiply those. And we're going to multiply, this is a grouping here. So it's 2 to the a plus 2, which is going to be x to the 2a plus 4. So don't forget to group those. Alright, so that's the first example there, 83.3. Let's go to 83.4. We have x to the a to the b power, y to the a to the b plus 2. And we're going to put that over x to the minus a. Alright, so let's go ahead and do the power rule on top. So a times b is ab, y to the, and we're going to distribute that, ab plus 2a, and that is going to continue over x to the minus a. Okay, the only thing we can do here is, because this negative here is in the bottom, that negative, if you remember, tells you that it's in the wrong place. So let's put it on top. Let's put it right there. And nothing is on the bottom anymore. Alright, do you remember that? That the negative sign means that we take the letter or number in front and its exponent and move it to its opposite place. Here it's in the bottom, so we moved it to its top. Oops, let's put the a on there. That might help. Moved it to the top, and it's no longer on the bottom. This is all over 1 now because it used to be down here, and we moved it up, and we could take the negative sign off. Alright, so let's see what we can combine. X to the AB, we can put that as x to the a plus ab, because these are the same, so we add the exponents, but we can't really add them, we'll just stick them together just so we don't have two x's. Y to the ab plus 2a, and that is our final answer there for example 83.4. And that's it for this lesson. Let's see, looking at the problem sets here, don't see anything weird. Let me at least show you how to set up practice problem B, just to keep you from being fooled. So we have m to the a minus 2, p to the a plus 1, all over m to the a over 3, p to the 2a. So remember, the division means you subtract exponents, but you only subtract exponents with common bases like m. So this is going to be a minus 2 minus a over 3, p to the a plus 1, minus 2a. Okay? Then you find the common denominator between those two, combine. Common denominator, well, you don't need a common denominator, we don't have a fraction there, so you just put those together and you get your answer. Now when you end up with one like c, you've got m to the x to the z power, z to the m plus 3 all over m to the negative x. So take this m to the x and move it up here. Take the negative sign off. Now you can combine all those. Alright, so other than that, I think you'll be okay with problem set 83.